we introduced NaviChoker, a walking direction presentation system using a small pneumatic shooter. Virtual space, augmented reality, and real-world interaction provide users with a variety of experience using not only visual but also haptic technology. It is widely used in entertainment, daily life, and simulations. TactSuit is a typical example of a consumer device that uses haptic technology. It is a vest that converts the upper part of the body and contains a number of motors. The motors can act independently and interact with the application. For example, when the user's body is shocked in the VR world, the users can feel some shock same place in the real world. In this way, haptic technology is familiar to us all, and everyone can experience it. This type of haptic technology is classified as a form of human augmentation. There's a lot of research on human augmentation. For example, the installation of automatic vent on crosses to control body temperature, and the application of electrical signals to the arm to feel the weight of virtual objects. In Liverpool, the device that much loaders installed can be used as a navigation device by utilizing the resistance. However, the user cannot use the device in a small space due to the large size of the device. Also, it is not safe to handle a large device without being able to see the surroundings, as it is assumed that a headset is worn. So the device is not practical use in real life. The force jacket is a device that uses air pressure to provide haptic feedback to the user. In this device, the actuators on the inside of the jacket can act independently and can be used in conjunction with the VR applications to reproduce the sensation of being wrapped by a snake or hit by a ball. However, this device can only be used in limited space because it requires a large device to operate. In addition, the user cannot use easily because its mechanism is very complicated. Therefore, we developed the NaviChoker, a small haptic device that can be used anywhere. In NaviChoker, 4 pneumatic actuators made attached to the inside of the choker and inflated to present tactile sensation. This is the system configuration of the NaviChoker. The device consists of a choker, pneumatic actuators, a silicon tube, and a syringe. A silicon tube connected with the syringe is attached to the actuator. By manipulating the syringe, the actuator can be inflated. The actuator is made of 0.08 mm polyethylene film. Making a pneumatic actuator is very simple. First, draw a 1.5 cm by 2.0 cm rectangle on a film. Then cover the film with a cookie sheet and place the rectangle with a solenoid iron. Finally, cut it out with scissors. This is how it works. Before implement user study, we verify the relationship between the presentation of pressure and the ejection felt by the user. We present a total of 15 tactile patterns to 7 participants. After that, the users records the direction in which the user feels. After collecting the data, we decided to use the pressure pattern for the user study. In the user study, 9 participants evaluated the system. As the experimental procedure, the user is guided to the destination only by the pressure presentation by the device. We didn't inform the user of the destination and made sure that the user had never been to the destination before. As shown in the video, NaviChoker guides the user to the destination. The user is presented with pressure to start walking, change direction, and finish walking. In this experiment, we use the Wizard of Oz method, and the actuators were activated manually. As a result, 8 participants were able to reach their destination only by pressure presentation. It suggests that NaviChoker can be used as a navigation system. However, one participant got lost in the vicinity of the destination. It was because the finished walking signal was perceived as retreat. So it is need to more research for appropriate pressure intensity and presentation position. After the experiment, we implemented a questionnaire survey using a 5-point Likert scale. This is a questionnaire used to evaluate the difference in direction up presentation, the pressure presentation, and the comfort of wearing the device. Here are the evaluation results. We obtained high evaluations from many participants for pressure and direction presentation. This suggests that the proposed device is useful for direction presentation. On the other hand, some participants didn't feel much difference in direction. The reason could be that the actuator didn't reach enough to the neck. To solve this problem, the inflatable size of the actuator is increasing, and the installation area on the neck. More than half of the users were not satisfied with the wearing comfort. It may be because some users do not feel comfortable wearing the device around their neck, and the presence of the silicone tube may interfere with a comfortable fit. It is necessary to insert a soft cross end to reduce the size of the actuator mechanism. This is the summary. In this study, we created NaviChoker, a pressure presentation device using pneumatic shooters to present walking direction to users. This device can be used as a navigation system. Conventional navigation system based on screen display and voice guidance have drawbacks such as encouraging walking and being difficult to use in noisy places. It is suggested that the proposed system overcomes these problems. This device can also be used to receive notification from smartphones, detect obstacles, and work with VR applications. Moreover, the users can use this device as a fashion item because of its natural appearance. Future work, miniaturization, automation, and diversification of tactile patterns. In particular, by automatically controlling the actuators, it is possible to achieve more flexible and complex motion and to continuously simulate the user's neck area. For this purpose, we aim to improve the device by using micro pump and solenoid bubbles. I think this is the conclusion of my presentation. Thank you very much.